to Part 3 of Competency 14. In this video, we will work with normal distribution. Before we move on, I need to note some finer points of normal distribution. There will be some basic properties that you will be responsible for, even though this is middle school. Yes, middle school students generally don't work with these properties, except see in my picture, my nice little drawing I have here, the placement of your mean, mode, and median in respect to if the data is skewed left or right. That does come up in middle school, okay, 7th grade, and every now and again 8th grade. So it depends on what's being asked or what activity they're doing, but yes, you are responsible for it. You will teach that. You do need to know those finer points. Now, for our testing points, there are a few things that you need to know out of this picture, as well as the empirical rule. Okay, when we discuss the empirical rule, we're talking about 68% of the data falls within one standard deviation of the mean of a normal distribution. That's our image. And notice you have your z-score at the bottom, okay? Well, your z-score, well, that's your standard deviation. And when they say within one deviation, they mean plus or minus, okay? And that is 68.3%, rounded to 68 when we say approximately. Okay, and it is an approximation. I've actually had to calculate all these, of course, in the type of classes I've taken, which again is beyond the scope of middle school. Okay, now please note that if we say two standard deviations, that's 95.5%. Okay, and if we say three deviations, that is the 99.7%. Very important. And in this symmetric normal distribution, the mean is 50% of the data and the z-score is 0. So it's like the big center starting at 0, and it is 50% of the data. So if you're not familiar with these things, go back in some old notes, go online, find out some more about this, because you may have a very basic question related to these percentages and these deviations. Okay? All right, so let's try a few questions. Number 1, use the image above to order the normal distributions according to their standard deviation size from greatest to least. Okay, so what they're asking is, look at your ABCD options. They're asking us to use the sigmas to order it. Okay, so what we want to do is look at this little zone right here. That's the correct order, because the greater the value of your sigma, okay, the flatter the curve will be. So in that zone, from greatest to least, we have red, blue, and green. So that is sigma 1, sigma 3, and sigma 2, which is option D. Okay, now let's go to number 2. Given a normal distribution with a mean of 15 and a standard deviation, and the standard deviation is 4, what is the percent of the data that lies between the values of 11 and 15? Okay, the first thing that we need to do is get our z-scores, okay? So let's look at z1 and then our z sub 2. Okay, so what are those? Well, we have to divide them both by 4. Okay, so what that is that is going to be your given value. Okay, and for 1, we're going to call this one 1 right here. So we're going to say 15 minus 11. And then for z2, that will be 15 minus 15. Now, as you can see, 4 over 4 is 1. That's 1 is our z-score for z sub 1 and z sub 2. That's going to be 0 over 4, and that's 0. So this is telling me, what is it telling us? It's telling us that this deviation is on the, here, we can use this image up here to take a look at it. If we had one standard deviation, we would be right, we would be, with the mean being 15, we would have 15 right here. Okay, and that's, let's say, at our 0 z-score. And then we have a 1 here. And obviously, that would actually be a negative, and then 11 would be right here. Okay, so we are to the left of our mean. Okay, it doesn't matter if it's negative or positive. What you need to see is that you're one standard deviation away from where the mean is. That means that we need to take into consideration, remember, you had that empirical rule. Okay, and on that empirical rule, okay, look, pretend like I can draw. It's a big stretch, I know. Okay, that empirical rule meant that if we had this right here, that's one standard deviation either way. That would be the 68%. Remember, we read this prior in this video. Well, if we're only from 0, here, let me use a highlighter. We're right here where I have it in yellow. Well, that's half of our 68%. Okay? Well, what's 68% divided by 2? 34%. Now, that was kind of a trick question. It wasn't a difficult question if you knew the quick little equation or little fraction that we use, our expression to get our z-scores. And you also had to know the properties of a normal distribution and what this 0 meant when you have from 11 to 15 and your mean is 15. You would have to know how to implement all those facts, okay? Number 3, given a normal distribution with a mean of 60 and a standard deviation, and the standard deviation is 5, what percent of the data lies between the values of 65 and 75? Okay, so what we need to do is find ourselves some z-scores. So I'm going to say this is connected to z1, and this one will be our z2. Okay, we find out what those equal. Then we have something to work with, okay, to set up our difference to get our percent. Okay, so let's have our fraction, and we should have 65 minus 60. Now divide by that standard deviation of 5. Okay, enter first z-score, 1. Now let's do our second one, and that will be 75 minus 60 divided by the 5, and that will be 3. Okay, so we have to subtract these, okay? All right, so I'll go ahead and start setting this up here. You may have remembered in the prior part of the video, we needed a new standard deviation. So it's between these two z-scores. So that's 3 minus 1 equals that new 2. So that's our new standard deviation, and it's within 2. So we divide by 2. Now, these z-scores, they come with a percentage, and they are empirical, okay? If you remember the empirical rule, okay? So if it's between 1, it's going to be 68.3. Now, sometimes we use 68, okay? And you'll see that on the internet in books. But to be a little bit more precise, 68.3, either one usually works to get us what we need, okay? And 3, within 3, that gives us the standard deviation, or rather the percentage of 99 0.7. And that's your empirical rule. Okay, so you just simply subtract those. Okay, so let's put that in the calculator and see what comes out. 99.7 minus 68.3. Okay, and let me go ahead and put 2 on the bottom, but let's talk about this numerator. And I left it as decimals. You will see online where they don't. If you change it to from the percent, I have here the actual percent value. If you change it back to a decimal, then you have to go back to a percent. That is going to waste time. Put it in as you see it according to the empirical rule, okay? Your values, okay? All right, so now let's push enter. And as you see, it gives us the actual number of 15.7%. It tells you what you need, okay? It's just a little trick I developed, uh, not to ask for the decimal value, the actual percent. So we have percent 2 minus percent 1, okay? The second one minus the first one, and then you divide by whatever the difference in, which would give you new deviation, which is a difference in your z-scores. Okay, let's move on to number 4. Approximately what percent of data falls between one standard deviation of the mean in a normal distribution? That's the empirical rule. That's what we just talked about. And that is, now they said approximately, okay? They said approximately. So this gives us, C, 68%. Okay, so this would be positive, negative, 1 deviation. B, what is that? That's positive, negative 3. We just discussed this in the prior question. Now for D, that is positive, negative 2 standard deviations. Well, oddly enough, what would A be? A is actually 50%. If you're talking about standard deviations, that is less than positive, negative 1%. You have to see it in perspective, okay? All right, now those all pertain to everything I just explained. These are all basic things that you should know about normal distribution. Okay, all right, so let's look at number 5. A certain company makes cell phones. The mean lifetime of a cell phone is normally distributed with a mean of, mean lifetime. Okay. With a mean of 38 months. The two mean words kind of threw me off there, but this is what's important. Telling us about normally distributed says, hey, you can use your basic, your properties. We're not going away from just the basic stuff. With a standard deviation of 4 months, what percent of the company's cell phones will last longer than 38 months? Trick question. Okay. If you just sketch really quick a normal distribution, and this image was given in the prior part of this video, and I think we've seen it in another video. Okay. This would be our mean. Okay. It would be at the z-score of 0, and it is 50% of your data. And if you saw also, the mean, mode, and median will be equal. For us, that mean is 38. So everything in the center is 38. This means that starting with your mean, 30%, those months, 50% of the cell phones have a life less than 38 months. Past 38 months, the other 50% will finally die out. So it's a 50-50 chance of your phone dying before or after 38 months. So if you get to 38 months, you say, okay, great. You could try it longer, but the percentages of it dying grow. They grow pretty quick as you go. Okay, this is the last question in this video. Again, thank you so much for the kind words, even on social media. It's amazing that people are saying that we're actually helping. I'm not expecting miracles. I'm just trying to help people get through the rough patches. It was really difficult for me to pass one of my tests. I don't think that's fair as far as mathematics. I felt like I should have been taught this already. So I thought, you know what? Let me help other people with the struggle. And it is actually working. So thank you for your kind words. And don't give up if you didn't pass the first time. Just don't never give up. If I wasn't persistent, I wouldn't made it as far as I did. Don't let it get you down. You keep trying. You got this. Just keep studying. Use all of the resources online. Use everything. Buy a book. Of course, if our videos are helping, use them, it won't hurt. Okay, put some time into it. You're putting time into yourself. Okay, thank you for watching, liking, subscribing, and sharing. Happy testing.